Thank you. And in this brief presentation, I'm showing you and illustrating you the two models that we proposed in the frame of our project. But before start speaking in detail about the two models, I just want to introduce them as a part of a broader family of the input-output framework. And I hope and I'm sure that many of you knows about the input-output analysis framework that actually is grounded on empirical, economic, or physical input-output tables. And here's just one example of the mathematical algebraic structure of those tables. Actually, these are collections of empirical, economic, or physical flows that are exchanged across regions and sectors within regions. So this table represents, as an example, the intermediate demand and supply of products across regions. You see Russia, EU, and rest of the world as just an example. And of course, the light red blocks, the international trades. Then the final demand block that collects the demand of households, government, and investments by each country, and of course also the trades of products across regions, and then the so-called environmental transactions. These data are provided by economic bureaus of many regions, and also are provided in the form of multi-regional tables mapping all the structure of world economic activity in a standardized way. And these tables are available and are the ground and the underlying data for building input-output models. And what are input-output models? Essentially, these models are starting from the empirical data that I have introduced in the previous slides, by defining the so-called technology matrix, so the technical coefficients that are characterized how each technology within each region is demanding for inputs of products coming from other sectors and other regions in order to provide one unit of its output. So this is basically the essential data that is required to build and to provide the Leontief production function that then could be used in an algebraic system of equation in order to derive what would be the output, the total output of each activity in each region, given a set of technology represented by the technical coefficient matrices that are likely to be produced if a given level of final demand is demanded by final demand agents. And of course, once this total production or total activity by each sector in each region is defined, then it is possible also to derive the exogenous or environmental transactions in terms of, for example, CO2 emissions, water use, land use, and other environmental transactions within the nature and the economy. So this is a general framework in its simplest shape, and based on this framework, then this can be elaborated and further elaborated and be transformed based on a linear programming model and enriched with other equations and side constraints in order to represent a greater complexity in production system. And to provide and to deliver final models that are specifically devoted to the analysis of peculiar problems. Now, the major world multi-regional data sets that are available are provided by agencies like OECD, of course, or are the results of EU-funded projects like the XIO-based project. For example, and each database provides a granulometry or disaggregation of sectors, regions, and products that, of course, is variable. And this just to say that depending on the research question that we have, we can select a database that is more suited to reply to this question. For example, we are relying on the XIO-based database if our objective is to provide an in-depth reply to some key questions from the technology point of view, since it has a regional coverage that is not so high, but it has a high level of disaggregation of sectors. Okay, so once a database is defined, depending on the question, the research question that that we need to address, then of course the input-output model can be enriched and can be transformed to be more complex than the simple algebraic form that I showed you in the previous slide, in order to represent some complex phenomena in the real world that we want to address. And one thing to say is that we have developed the DyNERIO Python package that stands for multifunctional analysis of region through input output, that essentially is a database handler. So we recognize that handling an input output data set, implying handling huge input output tables that may collect a lot of numbers that need to be handled in order to deliver detailed models that can be used for scenario analysis. And the DyNERIO Python package allows to handle such database in order to rearrange regional and sectoral structure, in order to model the addition and inclusion of new industrial activities or new commodities, to assess the impact of such industries and commodities, and then to perform various types of impact assessments. So handling numerical perturbation in order to assess, for example, what would be the impact on the overall, I don't know, CO2 consumption if a shock in the industrial production, so a structural change in industrial production of a region is exogenously imposed. Then, based on word input-output data sets that are handled by the DyNERIO package, we can provide the suited empirical data set that is needed in order to deliver models. And speaking about models, then we of course have developed many different type of models that fit different purposes, but for the purpose of the project, we believe that the world trade model with bilateral trade and the dynamic extraction and recycling input-output models are the one that are, let's say, useful in order to, or that are fit the research question of the work package we are involved in. One mention important is that we can use input-output tables also to provide some small conceptual models for teaching purposes and teaching. And we believe that, and we proved that in the past, using input-output tables in order to provide a simplified sketch of economic systems is very useful for teaching and for capacity building purposes. Moving to the second model that we are proposing, of course, this stems again from the input-output framework, but it results from integration of multiple approaches. So the ground is the use of input-output empirical mesoeconomic data set that is integrated with other modeling framework, I would say, in order to investigate specifically future pathways in terms of production, so primary extraction, recycling of rare materials for a transition process. So specifically, it integrates, beside the multi-regional input-output model, what we have called the technology capacity stock module, so a numerical model that enables to understand what is necessary to install in terms of technology capacity and what is disposed year by year. And in the end, as a consequence, or due to the capacity to be installed and the capacity disposed of technology, then the final module quantify what would be the extraction of new rare material and the contribution of recycling in such material in order to derive the net demand of rare material for supporting a transition process. So specifically, without focusing on details, the module, the multi-regional input-output model, is in charge of depicting a transition process. So, for example, by providing year by year what would be the scenario for changing structure of the energy system, for example, and so and of course also projecting the increase and prospective change in demand by defining these as based on a relative change in GDP year by year, and this in turn is leading to a change in the energy demand as endogenous parameter that is delivered to the second module that based on the energy demand and the technology specification of energy technology, for example, calculates the technology capacity to be installed and to be displaced year by year. And this is essential because the capacity stocks and then are then returned to the dynamic extraction and recycling module that determine region by region what would be the prospective demand for virgin materials, rare materials, and of course the contribution of recycling in terms of recycling in such materials. So it delivers a final net amount of material by region that is necessary in order to support the transition process defined by the exogenous scenario that provided as input to module 1. So this second model is focused specifically on assessing the impact of the technology shift or transition processes through years. Specifically, we use this model for investigating the prospective changes in the demand of raw material, and so we can understand also if the bottlenecks in the supply of such material may be a problem in future energy transition. But of course, since this model is grounded on input-output tables, then in the end, we can also assess many other variables, like, for example, the prospective change in CO2 emissions or other environmental variables through a dynamic change in the structure of the energy system, for example, or a dynamic change in final consumption habits, and so on and so forth. Or, for example, the impact on jobs, since the input-output tables are also providing environmental extension, but also extension in terms of factor use, so labor costs and jobs, for example. And in terms of SDGs, these are pretty much the same SDGs that are investigated also by the other, are addressed also by the previous model that I presented. And here's a list of possible of relevant publications in the field that are delivered and they can provide further information related to the DyNERIO model. Thank you for your attention.